Okay, it's working now. So one more time. So 2p times dp over dx plus p prime, which is dp over dx, plus 2x prime, which is 2. So I factored out dp over dx because these are two terms. They are like terms, but I cannot factor it. I cannot add them, right? I mean, they're not like terms. They have the same, they have the variable, but I cannot add 2p to plus 1. I can't. So I have to factor out. And finally, and move 2 to the other side. So then dp over dx will be negative 2 at the top over this. And that's the final. Good question. Anything else? Do we have anything else from this section? Well, I'm sure you're going to find something else and bring it to class on Thursday, I hope. So this is the end of chapter 2. So for our second test, we will look at also at chapter 3. Oops, I didn't mean that. Just 3.1 and 3.2. There is a lot of preview or review, if you want, of the algebra. And we're going to learn how to differentiate exponential and log. So let's look at 3.1. So exponential functions. The exponential functions, I'm sure you remember, but I will refresh your memory right here. The exponential function is a function that has a base and a power. The power is the variable. This is given. It's a number, but it's restricted. What do I mean by restricted? A can be a number between 0 and 1, not 0, not 1, or A can be a number greater than 1. Of course, we have two shapes. When we have f of x, let's say, as 1/2 to the x power, and when we have f of x, let's say, 2 to the x power. This one, when the base is greater than 1, and this one when the base is somewhere between 0 and 1. And when we graph these functions with a base less than 1, we know they look like this, always decreasing. When we graph an exponential function with a base greater than 1, we graph like a pandemic. That's the problem with this function. Because 10 people infected, the next day will be 10,000. 10,000, the next day will be 100,000. That's the problem with this function. And that's why we've been hearing for more than a year and a half to flatten the curve. We would like to do this, but at least to do this. But at many, many times in the last 2 years, it was doing this, right? So this, I never, you know, envision that I would tell my students that this is a dangerous function, but it is. We've experienced it for more than a year and a half now. So I don't want you to think that this is part of the graph, because it's not. I was just giving you examples. Okay, so the special exponential functions are with base 10, which is common exponential function. And the nice one that we like a lot is this one, which is natural exponential function. And what we're interested in here is just one thing, in addition to the graphs, of course. But there is only one thing that we're interested in here, how to differentiate. Basically, f of x equals e to the x. The derivative of such a function is the nicest of all. Look at that. So if the function is e to the x, its derivative is e to the x. Now, of course, if we deal with e to a function, it's a different story. e raised to a function prime, we have to use the chain rule. We have e to the function, but times the function prime. So, for example, if I have e to 4x cubed minus 2, and I want to differentiate this, I will write this piece, which is e to 4x cubed minus 2. But then I have to differentiate the inner function. Can anyone give us the inner function prime?
Well, that's there.
Thank you. That's it. Thank you very much. So now let's take a look at, that's it. Just to look at applications. Let's look at applications, page 304. You choose. Three oh four. We just want to practice differentiating any exponential function you want to look at. So anywhere between 1 and 64, and then I would like to look at applications with the same function. That's it. There is nothing else in this section. I'm ready when you are. Anything you'd like to choose. Or if you want me to choose the first one, I will choose the first one.
17.
17. Okay, we are choosing 17, and then I would like to choose 33. So 17. F of x equals e to negative 7x. I'm going to copy 23 as well. G of x, no, 33, sorry. 33. E to, so this is f of x, e to 2x over x to the fourth. Perfect. Okay, so let's start with f of x, this one. So what is that? It's e to a function prime, right? So let's find f prime. By definition, is e to negative 7x multiplied by the inner function prime, which is?
Negative 7.
That's it. Done. Now 33. It's a little bit more, requires a little bit more work. Because now I have function 1 divided by function 2, so I have to use the quotient rule. So what do we have in the denominator when we apply the quotient rule for this function?
X to the 8th.
Thank you very much. The square, x to the 4th, squared, copy the base, multiply the exponents. Thank you very much. So now, the numerator. I have to differentiate the numerator, so I get e to 2x times the inner function prime, which is?
2.
Excellent. Times the denominator, minus the numerator, times the denominator prime. What do I get when I differentiate the denominator?
Or x to the third.
Thank you very much. So careful, do not try to simplify in here. Please remember you have to factor first. So I will factor e to 2x, and I will factor x to the third from both, and also 2. So 2x to the third e to 2x. So let's see what happens. 2 is out, x cubed is out, but there is an x left, and e to 2x is out. So from this very first term, only x is left. Then I'm here, minus. X to the third is out, e to 2x is out, and I have negative 4, but I have only pulled out a 2. So what is left here?
A 2.
Very good. And now, only now I can simplify 3 of these with 3 of these and I have left x to the fifth. So that's the final form. 2 e to 2x, x minus 2 over x to the fifth. So final form, and that was 10, yes. Okay, so 2 e to 2x, x minus 2 over x to the fifth. Okay, we have time for one more. Please pick anything you want. Anyone? Which one?
53.
53, very good. 53 it is. So g of x equals 4x squared plus 3x and multiplied by e to x squared minus 7x. Perfect, perfect pick. Thank you so much. So of course this is function 1 and this is function 2. I have to use the product rule. Can anyone give us this prime and times that?
Eight x plus 3.
Thank you very much. And then now plus, I copy this. I copy this because when I differentiate it, I get x squared, e to x squared minus 7x, but times the inner function prime.
2x minus 7.
Awesome. Of course, I'm going to factor out this because it's common to both terms, e to x squared minus 7x. And I'm going to try and see if I can simplify in any way. So this is 8x plus 3, but here I have to multiply these two. 2x times this, 8x cubed, 2x times this, 6x squared minus 28x squared and minus 21x, because these are in a product. So I have to multiply. 2x times this, I get this. 2x times this, I get this. Negative 28x squared, negative 21x. So finally, e to x squared minus 7x. In descending order, this will be first. Here I have plus 22x squared, so these are done. And then negative 21 plus 8, which is negative, what is it? Negative 13, is it? And then plus 3. And this is final. We don't need to do anything else.